Uh, my name is Tom Girsch. My IT career is going on 30 years now, if you can believe that, and most of that time's been working with Informix, and learned a lot along the way. And I'm hoping to share some of it with you so that you can learn from it. Maybe you've got some things I can learn from as well. But today I want to talk about redundancy and how you get serious about it, and just how deep the rabbit hole goes, as it were. Looking forward to sharing with all of you. Topic of our presentation today is getting serious about redundancy. Uh, a good series of tech talks that Lester has set up, and I'm happy to help participate with this. So let's go ahead and dive right in. Maybe. Okay. First, get the guidelines out here. This is pre-recorded, so while I'm talking to you, I can actually be answering your questions in the chat. Please mute your lines so that everybody can hear and you're not distracting everyone. And as I said, use the chat button. Ask any questions. I'll be online trying to answer them as they come up. A lot to go through, so let's jump in. So here's your spoiler alert. This is what a good redundant system looks like. There's a lot to take in here, and we're going to get into all these details as I go through it. But I just wanted to make you aware that this is what we're aiming towards. If you went to my presentation that I did in Torrance a couple of years ago, this will look familiar, but there's actually been some updates since then based on things that we've learned. So moving forward, let's start with the obvious question. Why do you even bother being redundant? What's the point of all of this? Well, obviously, if you're in a 24/7 business or trying to be close to it, you want to minimize your downtime. But beyond that, you want to prevent losing data in the event of a failure. There's also some potential advantages to be gained by distributing your workload across multiple nodes and maybe even multiple sites. But the mantra that we're going to be repeating all the time is that things fail. And I have things in scare quotes for some reasons that I'll get to. There are some downsides, of course, to being redundant. Mainly, it's considerably more complicated to set up. And you're going to see that as we go through over the next better part of an hour, all the things you need to think about. It's also just vastly more expensive than having a computer doing things. You need many computers, potentially in many locations, doing the same things. And as with anything complex, you're trading one set of problems in terms of not having redundancy and not having available data for other sets of problems, just regarded to the complexity. But this is the mantra that we do all the time when we're thinking these things through. Eliminate single points of failure to the best of your ability, because the fact of the matter is things fail, and they fail with surprising frequency. So you want to be ready for it when they do. Where do we start then? Well, it starts at the host. You have a host with multiple CPUs. And I'm not talking multiple cores, I'm talking about multiple actual chips, because not all hosts will survive the loss of a CPU, but many will. And so if you have a multi-CPU host and one CPU fails, could be the host keeps going even at a reduced capacity, but it's still running. For the same reason, you want more memory than you think you need. Most modern hosts can disable a failed DIMM and keep running. So if you lose a DIMM, you're not dead in the water. Having redundant power supplies so that if a power supply fails, you're still up and running. But at the same time, it does you no good if those two power supplies are plugged into the same breaker and the breaker trips. So you want to make sure they're plugged into separate breakers. And you want them battery backed up if at all possible, so that even if the power fails, you still have power and you're still ready to go. Redundant storage. You don't want a disk failure to take you down. And even redundant network. You want to be able to deal with loss of a cable or things like that. So let's dig into some of those details. Start with redundant dedicated storage, because this is something that I've been talking about since my first presentation in San Diego in 1999, building a disk or storage subsystem that will survive outages, that will perform well for you. This is hugely important and always has been, remains so to this day. So I strongly recommend, I'm in the Art Cagle camp, I strongly recommend full mirroring. You can do some striping on top of that, but there are costs and trade-offs associated with that. I just like plain RAID 1 mirroring. Parity RAID modes, RAID 5, RAID 6, those are less reliable than full mirroring, and you sacrifice write speed, especially in the event that you have a drive that goes down. And we've talked about all this in detail in other presentations, but nonetheless, you need to be aware of it. Also, redundant RAID controllers, because a RAID controller is a thing and things fail. So what happens if your RAID controller goes out? If you only have one, your storage is gone. You don't want that. dual paths to disk. There's multiple benefits to this. If you have both RAID controllers having independent connections to every single disk in your system, then you not only do you get better throughput when everything is up and working, but if a controller fails or if that cabling from the controller to the drive fails, the other one can take over. And again, no shared storage between nodes because a SAN is in and of itself a thing, and that thing can fail. This is where I have a little bit of fun with what I call the true Gershywood stories. I'll have several of these throughout the presentation. These are actual incidents that I have had to deal with over the course of my career. This one I call the SAN incident. Back when I was working for a major hotel chain that may or may not rhyme with Milton, we had at the time, top of the line EMC symmetric SAN. And not only was everything redundant, everything in the unit was triply redundant. It had 3 of everything to try and protect you against all of these failures. And whenever anything did fail in this unit, it had a phone home capability, and it would just send out for a part. And within 4 hours, a guy would show up, and he would replace the part. One fine Friday afternoon, we had a power supply fail on the EMC Symmetrics SAN. No problem. It phoned home and asked for a replacement part. Great. I don't even think it notified any of our people. It's just a thing that would just happen. Then, within that 4-hour window, before that part arrived, a second power supply failed in the unit. So now, the EMC Symmetric SAN is down to 1 power supply. And the Symmetrics had logic built in that said, you know what? 1 power supply is too risky. If I have 1 of anything, I don't like that. That's getting us into a neighborhood now where we're at risk of data loss. And rather than losing data, I'm going to protect everybody's data by initiating a graceful shutdown. And it shut down the entire SAN gracefully, yanked the storage out from under our entire enterprise, and suddenly on a Friday afternoon at about 4:30, everything was down. So yes, even though you have this beautifully redundant SAN, that SAN is still in and of itself a thing. It can fail, and in our case, it did. And it was several hours for us to recover from that incident. So it's a good lesson in there for that. Things fail. So let's move on now to the network. Redundant network is also important. I recommend having 2 NICs because 2 ports on 1 NIC doesn't help you if the NIC fails. A NIC is a thing, and things fail. You also get better throughput because each of those connections can operate at its full speed when they're both up and running. What we've enabled is something called network teaming. You may also have heard it called bonding, which is slightly different. But the idea is that you take each NIC and you connect it to a separate switch. Switches are a thing. Switches can fail. So 2 NICs to 2 switches, on 2 separate cables. Both of these listen on the same address at the same time. And the driver behind the scenes handles the duplication. In the Linux world, what it does is something called ARP routing, where somebody will connect and it will negotiate the connection and it will send back an ARP message saying, okay, from now on, just connect on this interface until I tell you otherwise. And from that on, the packets will all go back and forth just over the one. But if something happens, then the driver will kick in and say, hey, you over the other cable, start operating on this one now. And so that way, if a cable or a switch or a NIC dies, you are still connected and you didn't even lose active connections. And then you can configure those in either a round robin or load balance mode. And if you do that, you double your network throughput, as I said, because one NIC can be handling half the traffic, the other can be handling the other half, effectively doubling it. But that's not enough even. Now you need redundant servers because the server is a thing. And what if the whole server fails? What if a CPU dies and the server's not one of those that will survive that? What if there's a power surge that just takes out the unit? What if you have the infamous ID10T error where somebody just pulls a dumb and turns off the wrong server or unplugs it or something? I've had both of those things happen. So how you fix that? You get a second server that you configure identically to the first. You preferably put it in a separate rack and connect it to even separate switches from the first on separate breakers with its own storage. And here's where it gets important. You want these, if you're really serious about this, you want these to be physical hosts and not virtual machines. There's performance reason for that. There's a troubleshooting reason for it. And there's the thing reason for it. If you have virtual machines, you might be sharing resources with other things that you don't even know about. And so they might be stealing your performance from you, and they could very well be causing trouble and making it harder for you to find. Ideally, you want a situation where every single server in your cluster is shared nothing. More detail. True Gershie stories number 2, the VM incident. Why not virtualize? Well, we had an incident, thankfully, that did not impact our database servers directly because none of our database servers are virtualized. But we had a VM cluster that briefly lost its connection to the network. Like less than a second lost its connection to the network. And there was a bug in the hypervisor that when that happened, it assumed something had gone horribly wrong. And it decided that the correct workaround or solution to this brief loss of network was to spontaneously reboot every single VM in the cluster. So not just the node. So we had situations where we had redundant VMs and they were on separate nodes. But because those nodes, physical nodes, but because those nodes were virtualized into one big cluster and that cluster was a thing and that cluster failed, everything, every single VM unceremoniously rebooted at the same time in the middle of a busy afternoon. So you need to be aware that that's a thing that can happen. So if you're clustering, I'm going to digress a little bit. Even if you're virtualizing things, it's important to have multiple clusters that are independent from one another because a cluster is a thing. Now you've got your redundant servers. You need them behind redundant connection routers too, because without something like a connection manager, how does a client know which host is primary? Where should it go? And if you've got only one CM, now that connection manager is itself a single point of failure. So if the CM dies, then what? So you need multiple connection managers. Ideally, connection managers, you don't put them on the same host as the database. You can get away with it if you have multiple database hosts so that that are independent, but I highly recommend against it. CMs are actually something that can make sense to virtualize, but as I just noted, you need to make sure that the multiple CMs are on separate virtual machine clusters, because we just discussed this. VM cluster is still a thing, and it is a thing that can fail. With multiple connection managers, failover, on the other hand, becomes an issue because which connection manager handles the failover? How does that work? So you have to make sure, and IBM Informix's solution is you have to make sure that each connection manager has a unique priority value. And the CM with the highest priority / lowest number, priority 1 is highest, priority 99 is lowest, or whatever it is, that will handle all of the failover. If you have multiple CMs from the same host or virtual machine, you got to make sure that only one of those has failover enabled. Now, why would you do that? As an example, we have a separate connection manager set up for people who are using PAM to authenticate versus straight Unix authentication. Rather than trying to run that under a single connection manager, we have separate processes doing that. We have the PAM one so that it does not handle failover. It's only the regular connection manager that does that. That's the reason why you might have multiple connection manager processes running on the same host or VM. So, where are we so far? We have internally redundant hosts with redundant power. They're each connected to dedicated redundant storage. Each is connected to redundant switches with redundant cables from redundant NICs, and they're running behind redundant connection routers that are themselves running on redundant hosts or redundant VM clusters. So that's pretty good, right? What are we still missing? What if the whole data center goes boom? You need redundant data centers if you're going to go that far. The data center isn't, after all, a thing, and it can fail. You might have a lightning strike or a catastrophic weather event or a natural disaster, long-term power failure. Somebody in the data center pulls a dumb. All of these things can and do happen in the real world, and you need to be prepared for it. So how do you get around this? With a second identical data center, a DR site, which you repeat everything that we've done already, and you do the same things all at a second site that you match as closely as possible to the first, so that either data center could, in a pinch, operate as a fully functional data center. The data centers need to be able to talk to each other, and they need to have connections to do that. And those connections need to be redundant, because if you lose your connection between the data centers, now you're not redundant as you thought you were. And all kinds of other problems can crop up that we're going to get to real soon. Spoiler alert. Location, of course, matters. If you have a data center right across the street from your other data center and there's a grid-wide outage in your region, it doesn't help you very much. We had an incident several years ago where most of the East Coast was out of power. So, you don't want to be in that situation where, sure, I've got two data centers, but both of them are without power because of the same event. So farther apart in this case is probably better. I personally recommend multiple time zones apart for personnel reasons. So now, internally redundant hosts, redundant power, dedicated redundant storage, redundant switches, redundant cables, redundant NICs, redundant connection routers, redundant VM clusters, redundant data centers, insufficiently distant locations. What are we still missing? Here's where we get to what I call the third TrueGirsch story, the WAN incident. We had everything that I just mentioned in place. And our data center, our backup data center was a co-located data center. Not only did it have redundant connections to the WAN, it had three. We had our primary connection, we had a secondary connection, fallback circuit that had every bit as much bandwidth as the first and was on standby waiting for us to use it. And then we had a tertiary lower bandwidth connection in case the first two went out. Well, we had a situation where our colo data center's primary circuit failed. No problem. Fail over to the backup, right? Except that their automated failover did not automatically fail over. So now we're dead in the water. That data center can't see anything in the rest of the world. Your failover is only as good as your ability to use it. We were up for the better part of a business day trying to move everything over to the tertiary circuit manually, and then eventually had to manually move it back because the primary had failed, the automatic failover to the secondary also failed, and that secondary circuit wasn't working reliably when we tried to manually switch to it. So we had a full day outage as a result of having everything redundant, but not being ready to use it. Which gets us to the failover topic. Your redundancy is only as good as your ability to fail over and use it. Can you fail from one host to another with a minimal interruption of service? Can you fail from one data center to another with a minimal interruption of service? And the more you have, so these are things that you need to know, and you need to test this, because the only way to know is to try it. That's the only way you'll ever know. And you don't want to learn in the heat of the moment. You need to work this through. The more you obscure all of this redundancy from your clients, customers, users, what have you, the better it is. You don't want them to know or care what the cluster looks like or what the data center configuration looks like. They just know I'm logging in to use your application or your service or whatever, and it works. When failover occurs, they shouldn't have to change anything. Maybe they have to disconnect and reconnect. Like, oh, lost my connection. I connect right back in. That's a thing that happens sometimes. I connect right back in, and boom, I'm connected. They may be connected now to a different data center on the other side of the continent or the world and not even know it. Right? That's good. You don't want them to know about it. You don't want them to have to get involved at that point. Your job is to obscure all of that from them. So here's a picture of what we have so far, where we have two data centers, what I call the main data center A on the left, data center B on the right, our DRDC. All of this is everything redundant. So you can see at the upper left, you've got two connection managers. Those are on two clusters, CMA1, CMA2. You've got your primary and your secondary database hosts, all living in data center A. On the right-hand side, same things, two connection managers, two hosts. I've got them set up using Informix HDR replication. One of them is an RSS, asynchronous. The yellow arrows are dictating asynchronous. The black line is dictating near sync mode. So we're careful to keep the primary and secondary very close to in sync. The RSSs we care less about. And you'll notice that B2 is on a delay. That again is for the ID10T error or for something unforeseen, maybe an attack, something like that. It is intentionally kept, depending on application, on a 12 to 24-hour delay. We have a time machine. We can go back in time in the case of mistake and recover data without having to do full restores. So you have all of this, and it's beautiful, and we are ready for everything, right? Not quite. True Gersh wood story. I leave the last one, an automated failover scenario. And to get into the weeds of this, you need to understand, we're going to need to review how failover works, because we had a 2 data center failover where we wound up with the dreaded split brain, which is why I chose this particular picture. And doing the postmortem, we figured out how we got to split brain. And once we understand this, we can understand a little bit more about how to prevent it. So first, understand how automated failover actually works. The highest priority connection manager wins, and it becomes the arbiter for failover. If the highest priority connection manager loses contact with the primary, checks the secondary. Secondary can still see the primary. It reports back, yeah, I can still see him fine. The connection manager says, okay, even though I can't see him, I'm not going to do a failover because you say he's still there, and I'm not going to mess with that. But if the secondary can't see the primary either, now it promotes the secondary, and the secondary becomes a primary. If the connection manager can't see the primary or the secondary, it'll work its way down the list through the nodes in HAFOC order in your onconfig file, and until it finds one that it can see. And if it can find one, it'll promote that. So far, so good. But what happens if, as in the incident I mentioned before, you lose your link between the 2 data centers? Now, data center A on the left looks good. Everything's fine over here. In fact, everything that you see in this picture is up and running, except there's no connectivity between data center A and data center B. Data center A is where most of the traffic goes. That's where everything's live. Everything's happy over there. Nobody who's connecting there notices any difference at all. Data center B, not so much. Data center B is in a world of hurt. Here's why. According to data center B, this is what the universe looks like. You only have those 2 connection managers, and you only have those 2 hosts, one an RSS, one a delayed RSS. Connection manager B1 is now the highest remaining priority connection manager. And it says, okay, I guess I'm the failover arbiter now. And it says, all right, can I see the primary? No, I can't. Can I see the secondary? No, I can't. I can see this RSS over here. Yeah, I can see him. Let me ask him, can you see the primary or the secondary? Nope. Nope, can't see him. Well, all right, I guess I have to fail you over now. And now B1, formerly an RSS, becomes a primary in this data center because it's the highest available node there. And now we have a situation where we have 2 data centers. This is now the view of the universe. I have 2 data centers, each with a primary. They don't see each other, but it's possible that clients in the outside world can see both. And each one has a primary. It never does anything other than promote nodes to primary. So the delayed RSS stays a delayed RSS. The secondary in data center 1 stays, or data center A, sorry, stays a secondary. But now I have 2 primaries and the split brain. And the split brain is hell to work back from. So you want to avoid this at all costs. So how can we avoid this situation? Well, the easiest answer is in a multi-data center setup, you only allow your primary data center, presumably one you're using most of the time as a primary, you only enable automated failover at that data center and not at the others. But that means that if you have a real bona fide data center failure, that means that your failover from one data center to the other is no longer automatic. It requires manual intervention to do. Is there a way to make it so that you can more safely do a multi-data center failover? Yeah, sort of. Stay tuned. We'll get there. But before that, I want to talk about management issues when you set up all this redundancy, because these hosts are only as good as your ability to use them, and you may be forced into using them for a lengthy period of time if you have a critical hardware failure on, say, your primary. So are your secondary and DR servers ready to become primary and take on those duties? Are all the appropriate user accounts set up? Well, this is a mistake that I've made where we had a failover and the database is up and running, but user X was never set up over there, so user X starts getting rejected after the failover. Don't want that. Are all the necessary scripts present that you might need over there? Are the various scheduled cron jobs configured and available? And are those jobs set up to run only on the primary when appropriate? Because then you don't have to worry about enabling them or disabling them. You can just leave them enabled all the time, And the first thing they check is, am I running on the primary? No, I'm not. Okay, well, then I'm not going to do anything. Oh, I'm running on the primary. I need to do this purge, or I need to kill these connections, or whatever it is that it does. Do your configurations, both physical hardware configurations, OS and software, does that all match? Is that sufficiently close together that you're not going to introduce problems when you flip? You need to have this bold because it's super important. You need to have procedures in place to make sure that when you update one node in a cluster for any reason, that you got to and add or change anything that we've talked about, you got to make sure that you catch them all, because otherwise you put yourself in a situation where your servers are not alike and you discover the hard way that, oops, we failed over, but this job never made it, and now I haven't purged in a month, or I haven't done whatever. So how do you get around the multi-data center problem? Well, I mentioned in the abstract that there are improvements to the product that could be done that would help with this. And 3 is the magic number here. Actually, odd numbers are magical, really. Other databases, such as MariaDB with Galera that we have in-house, or MongoDB, they don't do priority-based failover the way Informix does. Instead, they use a majority rules algorithm, which requires an odd number of nodes, at least 3. And so, in this case, the majority says who's primary, not the high priority node. And ideally, this requires a third data center, or at least a computer in a third location. So 2 data centers with 3 nodes each is 6 nodes. There can be ties. So you want, both within the data center, you want your odd number, and ideally, and across data centers, you want your odd number. 3 data centers with 3 nodes each works. That's 9 nodes, but that kind of seems overkill. So the way that I would recommend doing it is something like a 3-3-1. The bonus is that the third data center doesn't have to be fully built out. You just have that one node that acts as an arbitrator, so that if there's a data center connection link, you need to have that third guy or fifth guy to do it. On the Informix side, we do a 2+2+1, because there's no point in having 3 of everything in a single data center, because Informix doesn't do the majority rule logic right now. So 2 is fine for your redundancy. And that brings us to our final configuration. Imagine in this case, we have a main office that I've listed as C here. And I say it's a main office. Let's say that's where most of your users are, if you have that type of environment. So you set up a connection manager there in that office, and that becomes your failover arbiter. That's the only one where automatic failover is enabled. And now you still have data center A and data center B, as we discussed before, and they're configured as discussed before, but now everybody's coming out of the main office, coming out of C, and connecting through that, and C is the only one that can actually affect a failover. You can even have the users in C connecting to all of those connection managers in a round-robin or randomized fashion, and that's fine. What's important here is that only connection manager C is doing automated failovers, because that will avoid the situation where the 2 data centers don't know about each other, but all of our users do. So the place where all of our users are is the place that knows about where everything is and can do the failover. This is still not bulletproof, because in the situation as before, you might have a situation where the link is lost between the 2 data centers, and so now connection manager C promotes B1 to be the primary. But if you have your users connecting as the default way is in redirect mode, you may have users out there in the world that somehow still see data center A. Host A1 still thinks it's primary over there at data center A and is up and running, and those guys are still connected there. So you could still have a split brain problem in that regard. So if that's how your environment is built out, the way to get around that is to use proxy mode connections and have everybody connect through connection manager C1, and maybe even do a second or a third in that location, so that that connection manager doesn't become a single point of failure. But you could see just how deep the rabbit hole goes here, and how expensive and how management intensive it can get to be this serious about redundancy. And if you're doing all of this, you're probably not doing it because you want to. You're probably doing it because a regulator somewhere says that you had to. But nonetheless, this is what the picture starts to look like. Now, all this stuff, let's talk about licensing, because that matters. All of that hardware that you just bought and set up, and data center floor space and all of that, that's all very expensive. But now you still have software that you have to license. Per the IBM Informix license agreement, you have to license any database engines that accept user transactions. That means if no users connect, a true DR server is just sitting there, keeping the data up to date, but nobody's connecting, nobody's running reports, nobody's running jobs, then you don't have to license those nodes. But as soon as you start accepting user connections on those nodes, you have to license them. And they move, so if you have a failover event, as long as you're doing, we have in our case, we have 4 nodes, we have 2 of them licensed. As long as we're only using 2 at a time, we're good. If we start using 3 at a time, we're violating our licensing agreement. So you need to be aware of that. And you need to start thinking about what's more important to you. Do you want to be able to distribute your workload across those data centers and gain the advantages of all that extra hardware at the cost of licensing the software? Or do you want to keep the licensing costs down, license only what you have to, and use that second data center as a true DR type site? That's what you need to worry about. So, all of this, repeat our mantra, you eliminate single points of failure. It seems like we've covered everything, every possible single point of failure we've at least mentioned. But there's one that we're still missing, potentially, depending on your company or your environment. Your DBA. Do you have more than one? Your system administrator. In several environments I've been in, there have been times when I've been that single point of failure, and you need to think about that. What if your friendly neighborhood Tom gets hit by a bus? What if your friendly neighborhood Tom decides he's just done with all of this and moves to Bora Bora? What do you do then? So the people are important too. You need to make sure that you have multiple people in multiple locations that know how to do all this stuff and know how it's built out. And that's it. I'll be happy to stick around and take any questions. I've already been answering them in the chat. Be sure to subscribe to our YouTube channel. You've got the link here on your screen, and I'm happy to answer anything that you might have.